NASA Plus. Our story opens with a time-lapse of the night sky. Drone footage over lush mountains. Dr. Wanda Diaz, astrophysicist, is shown on stage giving a TEDx talk.
Nowadays, nature it feels as if all nature serenades with a mystic melody. And then it gets better. The spectacle gets better as I hear how galaxies arch across the celestial dome. What happens is that the information that the satellites gather is light. And usually, people like me who dedicate their lives to physics and astronomy, etc., convert that light, that information gathered by the satellites, into numbers. And those numbers can be converted into a sound.
So I have a very dear friend, Dr. Wanda Diaz. She is an astronomer and a computer scientist, and she's been blind since she was a teenager. She was really my inspiration. That's how I first learned of data sonification. She has told me these stories of how she would be in math class at university and her professor would just be writing equations on a board and she could not access that information.
Handwrites with chalk on a board. Wanda's TED Talk audience members don blindfolds to listen to solar flare data.
So for her to study the stars, she relies on data sonification so that she can translate that information to something she can hear and therefore process and therefore study. So for her, data sonification is an actual step of scientific research.
Solar flares erupt from the sun. Text on screen instructs the viewer. Close your eyes and listen.
Sound effectively increases the sensitivity of people to signal detection. And I think it's crucial that the training begins in school. Let's not leave out people with disabilities.
Blind students' hands touch astronomical models. The scene switches to a wide-field view of a galaxy with exoplanets depicted by circles and sounds. Christine speaks first from stage and then in a meeting with Matt, Andrew, and Kim.
Even if we're not scientists, I think that curiosity or that awe or that attempt to understand the cosmos and infinite space, I think that's something that all humans have in common.
It's kind of like listening to a poem in a language you don't know. Because if you're not a scientist, those concepts are, I won't say foreign, but they're just not in your everyday parlance. They're not things you deal with every day. So it's dense. There's so much to take in.
Worth the effort though, right?
Yes. Yeah, it's so rewarding.
The Galactic Center sonification is shown in X-ray data. Matt and Andrew work in their studio.
I first met Matt and Andrew from System Sounds at a visualization conference that we had all attended a couple years before the pandemic, and I really admired their work.
System Sounds is a science art outreach project. So the basic idea is that we take data from space and convert it into music and sound for outreach, to inspire, to educate, and to make space more accessible.
We just decided to work together to try a few of these data sonifications based on Chandra data and to see what happens. Because I really suspected that, with over 2 decades of operation, we have this treasure trove of a data archive with Chandra and with other telescopes from NASA as well. And we just started playing. We started experimenting with translating this information into new sounds, new ways of knowing.
Matt and Andrew work with sonification data on computers. Kim works on processing an image on a computer.
So the first time that I heard a completed piece all the way through, it was of the Galactic Center, this sort of inner 400 light-year region around Sagittarius A star, our very own supermassive black hole. And it's this wonderful, dense, busy, active downtown region of the Milky Way, right? There's exploding stars, there's these X-ray binaries, there are these beautiful loops of material, all these massive stars. There's so much going on. It's kind of like Times Square, right? And I'm so used to that data and understanding it visually that the first time I heard the sound, there were things in the data set that I had never really noticed before.
For the Galactic Center, we started by looking at what the data looks like, what are the patterns, and the important thing is to find out what's the story we're going to tell. It was a beautiful multi-wavelength image, so it had layers of recorded light, of optical, infrared, and X-ray light all combined into one.
The Galactic Center image and sonification are shown in various wavelengths and combined.
In most cases, the sonification results in music that is not humanly playable by anyone. And so we have to use computers and synthetic instruments to bring this music to life. But there are some examples where we actually do some real recording.
An ensemble plays a composition of the Galactic Center.
We assigned each telescopic instrument to a musical instrument, so they had different qualities of sound.
Piano, critalis, marimba, flute, clarinet, violin, cello, bass drum.
One very common question I get when talking about the sonification project is from musicians who ask, can we play this data ourselves? So that was the next goal, to get sheet music into the hands of musicians.
Ensemble Éclat plays Where Parallel Lines Converge, composer Sophie Kastner's sonic rendering of the Galactic Center sonification. Andrew Santaguida.
I grew up in Toronto, and I've been interested in music for my whole life. I started playing piano when I was like 5 years old. Eventually I went to an arts high school, and that's where I met Matt, who is the other half of System Sounds.
High school rock band performs in a club with full lighting and dancing audience.
Andrew is by far my longest friend. We met in grade 9 when I was 13. We just happened to sit next to each other in chemistry class, and then we found out we were also in the same music program at our high school. And years later, after high school, we joined the same band with a few other people from that high school. And so we've been creating music together in some form for a very long time.
7 animated planets orbit a star in the TRAPPIST-1 solar system.
In 2017, Matt and I converted a musical solar system they had found called TRAPPIST-1.
TRAPPIST-1 is a very exciting system of exoplanets. There are 7 Earth-sized planets, all orbiting a nearby red dwarf star. And this system happens to be the most musical solar system ever found, because these 7 planets are locked in an orbital resonance. So it's like they're playing the same song. They're all locked into a rhythm and playing a certain harmony.
The planets' orbits are depicted by colored circular paths around the red dwarf star. The scene switches to a field of colorful dots.
A lot of it's trial and error. You look at what's important to the image, or like what's important to the data. So what's the image about? Is it about how many of something it is, when it happened? We just look at what the story of the image is, find out what sounds can bring that out, and then we just try version after version after version until we get something that represents the data. It sounds like the image looks, but also stands out on its own as a piece of music.
I like that one. Yeah, I know. I don't know what they were.
So the first step is I sit down with Andrew and we look at the data or the image, and we think about all the possible different sonification mappings. So we do a lot of sketching and diagrams and really try to do this design stage very slowly and methodically. And then we get into the computer programming, and that can sometimes take a while. From there, we do a bit of music production to put the elements together, and then we send what we have to Kim and also to Christine for their consultation and their feedback.
Credits roll.
Chandra is the result of this international collaboration of scientists. We are managed by the Marshall Space Flight Center, situated at the Center for Astrophysics, our colleagues here at the Smithsonian Astrophysical Observatory, and all of our colleagues at the Marshall Space Flight Center and NASA's Universe of Learning. So many people, so many experts that really give their heart and soul into making this data possible and to helping this data get out into the world.